Okay, today we will be trying to solve this sample problem involving head loss, head losses due to friction. It's probably mayroon din tayong masosolve regarding sa paggamit ng Reynolds number, whether it identifying whether it is laminar, turbulent flow, then applying the necessary or appropriate solution to solve for the head losses. Tapos sinasama na rin natin dito yung konsepto ng pumps, no? Yung effect niya sa fluid flow in pipes. Okay, so let's read the problem. So a pump 80% efficient delivers heavy oil with density equals to 912 kg per cubic meter and dynamic viscosity of 2.05 times 10 raised to negative 4 square meters per second through a 500 meters of pipe of 5 cm diameter pipe to a storage tank whose oil level is 3 meters above than that of the supply tank. For a flow of 4 liters per second, determine the input power of the pump. Okay. Madali lang tong ganitong problem. So, baka ma-overcomplicate nyo lang pag iniisip nyo kung paano isosolve yung problem. Tip number 1 is don't overcomplicate things. So, try nyo lang isolve in the simplest way kung paano yung figure nya. Para mas ma-picture out nyo yung situation. So if I'm going to draw this in a figure, ganito ko siya gagawin. So kung meron tayong supply tank, drawing natin sa supply tank, nandito siya. Tapos merong oil level dyan. Tapos lagay natin yung pangalawang storage. So ito yung oil surface nya. So isa lang naman yung sinabi ng problem regarding sa dalawang elevation, sa dalawang levels. So pwede natin siyang sabihin na ito ay 3 meters. Kasi sabi ito raw ay 3 meters higher than that. Okay. So meron daw pump. Sabihin natin nandito si pump. Dito na lang siya pinadaan sa ibabaw. So, kuha siya ng supply galing dito sa container na to, then papunta dito. Okay. Ito si pump. Malinaw? So, yung flow natin is from, sabihin natin dito si point A, dito si point B. So, ang flow natin is from point A to point B. So, dadaan siya sa pump, papunta sa pangalawang storage tank. Okay. So dito yung supply, and dito yung storage. Okay. So yung total length daw ng pipe is 500 meters and the length and the diameter is 5 cm, which is equal to also to 0.05 meters. Okay. So at this point, di pa natin alam kung paano natin siya isosolve talaga, no? So mayroong piniprescribe ng libro mga mas mabilis na solution kasi dinerive na nila yung mga mas mabibilis na formulas, no? Pero katulad nga ng sabi ko sa inyo, I personally would like to solve this gamit pa rin, pabalik pa rin tayo kay Bernoulli energy equation kung saan nagmula din naman yung mga ibang formulas. Okay? So yun. So try natin, diba alam naman natin yung flow. Ang flow natin is from point A to point B. Okay. Sulat natin yung energy equation. So meron tayong velocity head at point A squared over 2g plus pressure head plus elevation head plus energy output ng power. Mamaya explain natin bakit siya energy output ng power. Then isa-subtract natin lahat ng mga frictional losses. Okay. In this particular example, neglect muna natin yung mga minor losses, no? Para simplihan lang muna natin. Since madali lang naman, maliit lang naman yung effect ng minor loss dito. So, then it is equal to the energy at point B. So, BV squared over 2G. BV squared over 2G plus PB over gamma plus ZB. Okay, so yan na yung ating Bernoulli energy equation for this problem. Okay. So maraming paraan, no, para i-draw itong figure na to. Basta ang mahalaga, wala kang nilalabag na mga parameters na binanggit sa problem, and the answers will be the same. Baka kasi makakita kayo ng ibang interpretation ng problem, pero for the same problem, pero definitely same lang yung answer na makukuha natin. So isa-isa natin identify kung ano-ano yung mga values ng Bernoulli energy equation na ating na-derive. Okay, so at point A, the velocity head is negligible. Yan, no? Katulad na banggit ko, for a very small value of V, no? For a very small value of VA, then in-square mo pa siya, lalo siyang liliit, tapos yung maliit na value, dinivide mo pa sa 2G, that will give you an almost very small number, no? Kaya natin siya tinuturing na as negligible. Plus PA, since exposure sa atmosphere, the value of this will be 0. Then ZA, so pwede naman natin establish na itong elevation A na to as datum para mas madali na yung ating computation. So wala namang problem doon. So ZA will be 0. Then EPO, so bakit unang tanong natin, bakit siya ginamit as output? So bakit nga ba? Ang binanggit dito sa problem is determine the input power of that pump. Okay. So kung matatandaan nyo, ito binanggit din dito yung efficiency ng pump, which is 80%. Ang na-experience ng system is not the input power pagdating sa pumps, no? Ang na-experience ng system in this case is the output power. Ibig sabihin, pag pumasok sa kanya yung flow, lalabas sa kanya at na merong energy, pero hindi niya na-attain yung maximum efficiency na 100%. Kasi walang machine na gano'n na 100% yung efficiency. So merong nawawala in the process ng pagpa-pump. So yung na-experience ng system is the output power, no, for the pumps. Okay? So mamaya masasolve natin yung value ng EPO. Then yung HF, wala pa tayong value ni hindi pa nga natin alam kung anong formula yung gagamitin natin. Okay. Punta tayo ron sa kabilang side ng equation. So sa point B, ganun din, yung velocity head niya will be negligible. Yung pressure head niya will be 0. And then yung ZB niya will be 3 meters. Okay. So pag sinulat natin itong equation na to, ang matitira na lang sa atin ay si EPO minus HF is equal to 3 meters. Okay. So since ang hinahanap natin dito is EPO, para magagamit natin siya mamaya sa pagkuha ng power, no, na P is equal to Q gamma E, no? So Mamaya natin masosolve yan, no? Yung input power na to. So, unahin natin i-identify muna kung ano ang ating HF or yung total loss due to friction. Okay. So, since hindi pa natin alam kung ano ang ating tawag dito. Hindi pa natin alam kung anong ating formula na gagamitin. So, identify muna natin, no? So, itong si ating Reynolds number. So, si Reynolds number mag-identify. Dalawa kasi yung pwede natin gamitin na formula, di ba? For the head loss. Kasi kailangan nating i-identify kung siya ay laminar or turbulent flow. So, yung una natin na pwedeng gamitin is si HF is equal to HF is equal to F L over D V squared over 2G. This is the Darcy-Weisbach equation, which is only applicable for, or pwede mo lang siyang gamitin for turbulent flows. Flows only. Tapos meron tayong isa pang version, which is the Darcy-Weisbach equation na na-derive natin from Hagen-Poiseuille equation, which is HF is equal to 64 over RE L over D V squared over 2G, no? Where RE is Reynolds number, and the rest is identified naman na natin. So lumalabas dito sa equation na to, no, as we have mentioned before, that this is equivalent to the F, which is the coefficient of pipe friction, coefficient of pipe friction. So una nating isosolve is kung siya ay laminar or turbulent, kasi itong unang equation na to is for turbulent nga lang, and ito naman is for laminar flow. So let's solve for RE. So the formula for RE is equal to yan. So VD over, sorry, mali. VD over, saan yung aking correction tape? Kunin ko na lang. Over the, tawag dito, kinematic viscosity. No, kinematic viscosity. So madali na yan. So RE will be equal to V. Alam ba natin yung V? The velocity. Alam lang natin yung flow. Alam lang natin yung flow na Q is equal to 4 liters per second, which is equal to 0.004 cubic meter per second. So alam natin na ang formula for V is equal to Q over A. So pwede natin siyang i-convert, Q over AD over V, or kinematic viscosity. So substitute natin, Q is 0.004 cubic meter per second over area. Area is pi times D. Diameter is 0.05 meters squared over 4 times the diameter, which is 0.05 meters. So makakancel natin to, tsaka ito. Tapos all over, baba ko itong si RE, and all over kinematic viscosity of 2.05 times 10 raised to negative 4 square meter per second. So which gives us, sorry, ito lang pala yung burahin mo dyan, may matitira pang 0.05 dyan. So RE will be equal to, let's try to solve. 0.4 to 0.4 over pi times 0.05 over 4. Tama pa ba ito? Times ko na lang siya sa 0.25 divided by 4. Then all over 2.05 times 10 raised to negative 4. So may nakalimutan pa ba ako? I think wala na. Which gives us the value of the Reynolds number na 496.87397. So RE pa lang yan, wala pa yung final answer natin, no? So i-store ko to sa A para hindi ako mag-round off at ma-eliminate ko yung error. Okay, so since meron na tayong RE, alam natin na siya ay laminar kasi less than siya ng 2,000, dahil less than 2,000. So ang gagamitin natin na formula ngayon is yung HF, where yung HF galing sa Darcy-Weisbach equation na dinerive from Hagen-Poiseuille equation na 64 over RE L over D V squared over 2G. So yan. So kopyahin ko lang itong meron tayong values na RE is equal to 496.87397 na nakastore sa A. Tapos gagamitin natin siya sa formula na HF is equal to 64 over RE L over D V squared over 2G. So HF will be equal to 64 over 496.87397. L is 500 meters. D is 0.05 meters. V squared. V squared is something na hindi natin sinolve kanina, no? Pero alam natin na, sige, solve na lang natin sa CV from Q. So V is equal to Q over A, where V, gagamitin natin itong 0.04 cubic meter per second over A pi 0.05 squared times 0.25. V is equal to 0.004 times pi times 0.5 squared times 0.25 gives us 2.0371 8 meters per second. So store natin to sa B. Yan. So gamitin natin to, which is 2.037 meters per second over, so square natin to, 2 times 9.81 meters per second square. So HF is equal to, so 64 times 500 times 2.037 ay alpha B squared over alpha A times 0.05 times 2 times 9.81, which gives us a total value of HF equals to okay, lang. So 64 times 500 B squared 496.05 2 times 9.81. So 272.455 meters. Store ko to sa C. So balikan natin yung kanina, yung equation na tira natin. Ito no. Yung EPO minus HF is equal to 3 meters. So EPO, so yan, EPO, ay yung equation 1 natin is EPO minus HF is equal to 3 meters. So EPO is equal to positive 272.455 plus 3. EP is now equal to EP is now equal to 275.455 meters. Ngayon, pwede na natin, ay EPO. Yan. EPO yan. So, paano natin ngayon solve si power? Kung kaninang formula natin, si power ay equal to Q gamma E. So, ang gusto natin makuha ngayon is si power input. Tama ba? Ang nasa problem natin ay si input power. Determine the input power of the pump. Input power of the pump. So, P nung hanap natin. So ibig sabihin ang hanap natin si EP in din. So si EP in is equal to EP out over 0.8, which is efficiency nito, efficiency ng pump. So substitute natin yung mga alam natin na na value. So EP in is equal to Q 0.004 cubic meter per second. Gamma is equal to 9.81 kilonewton per cubic meter times the density over 1000. So 912 kilogram per cubic meter over 1000 kilogram per cubic meter. And then the EP in, which is EP out over 0.8. So EP out is 275.455 meters over 0.8. EP in, store ko to sa D. Ayan, sa D. So 0.004 times 9.81 times 0.912 times alpha D over 0.8. It's 12.32 kilowatts. Okay, so that simply means that the input power is 12.322. So kapag ang na-experience ng system natin is yung 80% lang. Ito yung kanyang 100% na kakayanan, pero dahil may mga losses sa loob ng pump, no, habang pinaprocess niya yun, nagkakaroon siya ng losses na nagiging efficiency niya is bumababa to 80%. Pag minultiply natin yun sa 0.8, ito lang talaga yung pumapasok sa system talaga, which is 9.8576 kilowatts. Okay? So, ganun lang siya kasimple. Yan. Yan. So, balikan natin yung first page ng ating solution para mabalikan nyo. Pwede nyo siya screenshot or i-pause. Yan. 5, 4, 3, 2, 1. And second page.